and we'll get into what we're doing today. Okay, so let me just start off with our announcements. I'm going to share screen with what we're, come on, share. There we go. So here's what I know from now. I think yesterday there was a message, I think it's called an all call. But anyway, I think a message was sent to most people that we could get a hold of yesterday on how we do attendance. And some people this morning were saying the same thing. So I guess you don't necessarily need to go to the Zoom meetings in order to get counted for attendance. I think we accept other things like phone calls and stuff like that. But it's going to be kind of tough for phone calls because, like, if my phone rings, it's all the way across the room right now, and I can't run over there every single time to stop and go get it. So email is probably the best way. And if I miss it, like if I miss a phone call, you know, if I miss your email, then at least I'll get it later. Okay, I'll update it whenever I get a chance. So that's still the best way to check in for attendance. But then I think they also said doing the work was also counted for attendance as well. So that's another way you could do it. My plan is to post these videos in the future so that way, again, for people who missed the courses, they can go back and watch these videos and not have to really attend the meetings. So I'm not sure, because I had some students that were telling me this morning that they were having trouble getting on the meetings. Their data was bad. They have splotchy internet, bad internet, whatever. And you know, I'm trying to find something that works with everybody. So the announcements that we had were iPads are available should be available around August 31st. So if you don't have a computer, which I'm guessing you do because you're here, or maybe your computer is not really that great and you need a better one, or maybe you're using your phone. But anyway, yeah, by August 31st, we should be able to hand out iPads. And also on that same day, Schoology will get running. I think I had some people yesterday saying that they wanted the notes for the assignments and the lessons in the packet. So hopefully I'll be able to upload those to Schoology once it becomes available after August 31st. But until then, I might have to make paper packets, but that's also a tricky thing because the paper packets are not really, right now it's kind of a sore subject because we're running out of paper and toner or ink at the school. So they don't want us to print so many things, so they want to try to keep it to a minimum. And September 3rd is family orientation. That they told me to let people know that that's what's going on. Anyway, let's go ahead and start with our lesson today. So here's where we left off yesterday. So we're going to complete this. I think we're going to go through about, I don't remember exactly how many it was. I think it was, well, when it had like 8, 10 examples, probably not more than 10 or that many more. So if you look at your packet, uh-oh, where did my packet go? But anyway, depending on how the packet was put together, I just remembered I'm making more of them, so it's probably still on the copy machine. But yesterday we did rational exponents, and that was the lesson that we did. So we're going to finish that up. So you should be able to finish them because I know some students were asking about some of them. So yeah, like the last 4 we're going to cover right now. And then we're going to move on to the lesson that we're supposed to be doing today. And that's going to be the back side of that same paper. So there are going to be more assignments on there because they wanted 2 weeks worth of assignments if they could. So I made them back to back to save space, save paper. So if you're hearing this, then that kind of makes it a little bit easier on you because now you know that you don't need to do all of it. All right, because I do have some people asking about that, saying that they run into trouble with it, but don't worry about any of that right now. So if you're listening to this, you have a really good idea of what's going on, much better than anybody who's not coming to these. All right, so anyway, this is the back side of that page 4 on the packet that we were working with. So let's go ahead and go into power rule with rational exponents. So here I have a base x to the 3/5 power raised to the 1/2 power. So we have a power of a power. And this part's missing a little bit, but if you do something like that, power to a power, you need to multiply the powers together. So that would be m times n. So again, you're multiplying the powers that are there. But since we're dealing with rational exponents, you are going to run into numbers that are fractions. So we're going to have to do a little bit of review on how to work with fractions. Okay, so again, same base of x. Grab 3/5. I'm going to make it a little bit bigger than I normally would, because I'm still using the mouse to write. I think I told you already this, but I got a tablet, but the thing didn't work, so I ended up having to return it. So back to using the mouse. Okay, so now I set it up so we have 3/5 times 1/2. So if you remember multiplying fractions, this one's kind of the easiest one because it's the one that kind of fits with what you mostly already know. All right, it's intuitive. So I'm going to multiply my top numbers together. So 3 times 1. 3 times 1 is 3, so that's my new top number. And now multiply the bottom number, 5 times 2. So 5 times 2 is 10, and that's going to be my new bottom number. And we got to check it because there's two things that we have to check it for. We've got to make sure it's in simplest form. And we do that by checking to see if we can divide it or reduce it. So divide or reduce. I don't know if I can type that out maybe. Oh. Ah. All right, that doesn't work out as well as I had thought, but oh well, trying new things. So again, divide or reduce. Just like anytime you're working with any other problem and you have a fraction, always see if there's something that you can do to simplify it. Okay, so there's nothing we can do because 3 and 10 don't have any numbers that they can both be divided by. And 3 is smaller than 10, so we can't divide it, so we're done with that one. I'm going to put a box around it to show that's the answer. Now, let's go ahead and work with this one here. So moving on to the next example. And one other advantage that I think is good for recording these lessons is that if you want to, you can pause or rewind it or play certain parts over again. So maybe if you were, something came up and you had to divide your attention, then you can always just come back and work on the parts that you missed. So anyway, there we go. I set it up. So 3/4, and I'm going to need to multiply it. So multiply the powers because we're raising a power to a power. And I'm going to go ahead and multiply my top numbers. Let me make the fraction bar, top number of 6, bottom number of 12. Now again, I can't divide it because 6 is a smaller number than 12, but I can reduce them, right? I can divide both numbers by several other numbers, like 6 and 12 can both be divided by 2. 6 and 12 can also be divided by 3, but I want the largest number that we can divide out of both of them. So that would be 6, right? Because 6 can be divided by 6, and 12 can be divided by 6. So 6 divided by 6 is 1, 12 divided by 6 is 2, so that'd be x is equal to 1/2. Who's doing that? Anyway, here we have something else. So this is kind of a different thing. If you remember from yesterday, we were working on exponents. So what happens when we have different exponents? I'm going to switch over to that screen just really quickly. Oh, I'm looking for this one. Here we go. So remember, when we have the powers decreasing, right, the number is dividing each time. So we have half, 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 half. So our number is getting smaller by half each time. But there is kind of a weird thing here, and that is, let me change the color. Let me see if we can change the color here. Let me see. Okay, so there must be something going on here. Let me try this and or I'm not sure if that's better. All right, let me know if you're having any problems with the screen. Hopefully it's better now. I don't know why it's doing that. I'll probably have to find a solution to that later. Okay, so not sure what happened there, but anyway, so looking at yesterday, what happened yesterday is that we have negative exponents, so 1 and -1. So looking at these two numbers, we have 2 and 1 over 2. Here we have 4 and 1 over 4. So we have the numbers, they're just reciprocaled. So 4 and 4 over 1, and the reason why we put a 1 over it is because when we reciprocal it, well, okay, these numbers have not been reciprocaled, but it's one of those properties in math that we call identity property. And that says that 5 divided by 1 is 5, right? Or any number for that matter. Any number divided by 1 is always going to be that same number. So what you do is you take a number, like if I want to reciprocal 4, first thing I got to do is put a 1 under it. And, well, not equal. It's not an equal. We're not doing anything. But if I want to reciprocal it, I just flip the number so it's 1 over 4. So again, we saw some of that going on yesterday. So basically, what we're going to do today is if you see a negative exponent, all you have to do is flip that number. So here I have 4 over 9. And what we got to do is we're going to flip it. 9 over 4. Okay, and then, okay, and then what that does is it takes the negative off of our exponent. So the exponent doesn't change, but now we have the number flipped. We took the reciprocal of it. Now what that does is it allows us to work with the exponent because we don't have to worry about, you know, negative exponents or anything like that, because if you have a negative exponent, you can't really work on it just like that, right? You need to do a couple of steps before you can actually start working on it. So that's all there is to that one. I don't think you need this one for the homework for today, but this is something that's going to come up later on in the future. I know the next few lessons, while we're still working with exponents and radicals, we are going to have to kind of work with negative exponents and reciprocals. Anyway, so the next one is something else that we also covered yesterday, and that is 0 power. So if you have a number with a 0 power, like in this case here, I have 2 to the 0, remember we get 1. And I think I said something like any number to the 0 power is always going to be 1. So if you take 100 and raise it to the 0 power, you are still going to get 1. It's always going to be 1. Because 1 is in the middle of any set of exponents that you can get, right? So in this case here, it's the only number that cannot be reciprocal, kind of like how 0 is the only number that cannot be negative. But don't worry about that. You don't need to know any of that for this. You just need to know that anything to the 0 power is going to be 1. Just like in this example here, I have x to the 3/4. And if I raise it to the 0 power, it doesn't really matter what else there is. It's just going to be 1. And that's it. We don't need to worry about flipping anything or multiplying anything or moving any numbers around. Anything to the 0 power is just going to be 1. All right. Now, if this was a normal class, you know, you'd be in here for about an hour, hour and a half, roughly. So we'd have a lot more exercises to do, but I'm going to try to stick to the ones that are most pertinent to the homework, the ones that the homework, you know, you're more likely to run into those ones. So I'm going to go ahead and move on. And I might end up skipping some of these. I think the main one we need to focus on, again, my packet's not with me today. The ones we really need to work with are these ones that say evaluate. So on the yesterday's homework and on the today's homework, it's going to have some of these where you are going to have to evaluate. And I try to point this out whenever I can because I know there's a lot of confusion when it comes to directions, especially with math. One of the more common things is every single time there's a math problem of any kind, the students always say, solve it, okay? Now, solving only works with algebra problems where you are trying to get the letter by itself to figure out what that letter needs to be in order to make the equation balance out or to make whatever a true statement. All right, but evaluate means you take care of everything. Just write that out. So there you go. Evaluate means take care of everything. So if you see something that you can do, like an add, subtract, multiply, divide, power, square root, cube roots, anything that you can do, you got to do it. So you got to take care of everything. Don't leave anything undone. Okay, so like I said, these are the main ones that we need to worry about to get through the homework. So 9 to the 1/2 power. So just like we did yesterday, we're going to transform this into a radical expression. So we need a radical. Take 9, and that base becomes our inside number, our radicand. Bottom number, so that becomes our index. And again, you think of it kind of like 1 divided by 2. And on a division bracket, the outside number is the one you're dividing with, and you get 1. Now, there's supposed to be a 1 there, but I think that 1 would probably confuse more people, so I'm going to go ahead and take that off. And this makes a lot more sense. Now, I could also take off the 2. We don't really need that. Because if you see a radical without an index, remember that it's automatically 2. But I'm going to leave it on there because if you look at my calculator, the square root button has the 2 on there. So sometimes people leave them on there. So you would probably see it both ways. So taking the square root of 9, we are going to get 3. There we go. And that's it. We took care of everything. There are no more divisions or fractions or anything. No other signs or symbols, just 3. So that's how we know it worked out. Okay, that was an easy one. Let's do, I'm gonna go down here. I think for most of these, I think normally I'd go across, but now I'm gonna kind of stick to one side and work my way to the other side. So let's go ahead and put this into a rational expression. X, take the square root of that. Oh, wait a minute. We're going to have to take care of a few more things first. Well, before we put it into radical expression, we are going to need to multiply them. So we're going to have to use one of those properties that we used earlier. So I'm going to take my 6 and turn it into 6 over 1. And again, you can turn any number into a fraction by putting a 1 underneath it, because 6 divided by 1 is still 6. You still get the same thing. It's not going to change anything. So let's multiply that by 1/2. Now I can take care of this fraction exponent, so that way I only have maybe 2 numbers in the exponent rather than, in this case, 3 or 4. So 6 times 1, multiply my top numbers. And for the bottom number, we're going to multiply our bottom numbers to get our new bottom number, 1 times 2. And again, if you can divide it or reduce it, let's do that. Let's divide or reduce it. 6 divided by 2 is 3. So now we just have x to the 3rd power. So we divided 6 by 2 and we got 3, so we can't do anything else. There's nothing else we can do. Maybe if x was an actual number, like 2 or 3 or 5, we could multiply it 3 times and get what we're supposed to do, but we don't really have anything to do here, so that's it for this one. We don't need to do much else. Okay, I'm going to scoot this over, and that's why I said I was going to do one side first. So I'm going to move it over just a little bit, maybe leave it a little bit in the frame. Okay. Now let's go ahead and take care of this next one here. Okay. Now I'm going to have to set it up as a radical expression. At this point, I don't have anything else to do. I only have the base and the 2 numbers that make up our exponent. So I don't need to do anything. Let's just start putting in numbers. So 36. And next thing I usually do, I usually have a process, and the next thing in the process is to take care of the index. So remember, our index also means you need 2 of those in order to get out. You need 2 of the same numbers to get out. And our top number becomes the power in here. So 36 to the 3rd power. And you could use a calculator, which, you know, you could use a calculator. In fact, you know, for this first one, I'm going to go ahead and use a calculator just to maybe get the idea. So bring up my calculator, and 36 times 36 times 36. And we get a really big number. We get 4,656. Push the square root button, and we can get 216. Now for some of these, I'm going to go ahead and allow the use of a calculator because, well, there's not really any way for me to tell that you're not using one. And I think calculators are just now sort of everywhere, and everybody sort of just carries one. And it's not a big deal as it used to be. So there we go. And there is another way to do this if you don't have a calculator, or maybe you want to use a different method. I'll go over that one later. But anyway, we're done with this one. Now for the last one on this page, we'll go ahead and go over these ones. Now, before I put it into a rational, before I do that, I'm going to have to take care of these numbers here. Or can I? Now for this one, look at that 4. There is something different about that 4. We're not really multiplying it here because, well, the 9 doesn't have a power. Now this is actually a different property I think we're going to get into later, but there is a way you can do this. And my first initial instinct was correct. We're going to have to take the square root because this bottom 2 becomes our index, and we put everything under the radical. So we're taking the square root of 9 and n to the 4. So let's take the square root of whatever we can. So yesterday I also talked about prime factorization, and remember that's like breaking numbers down into groups using a factor tree. I'm going to do that same thing here. So 9 is made from 3 times 3. And I remember I used to have a high school teacher. I don't remember exactly who it was or what their name was, but I remember they always had the saying, when in doubt, write it out. So I'm going to go ahead and write out 4 n's. That way you can see it, and hopefully it makes a little bit more sense, you know, why you're doing this or how it works. And I'll mention a little bit more of that later when we have a bit of a pause. But now this index is telling us, like the carnival ride, we need 2s. We need 2 people to get on each ride. So this means I can fill up 3 carts on this carnival ride. Or maybe it's like the prom and you have to go as couples, not as singles. No single people allowed. Sorry, Beyonce. I'm kidding. I don't know if that's even the same right song. Anyway, so I take out the 3, so it becomes 3. And I have a set of n's, right? I have 2 n's. So rather than saying n, I'm going to write n squared. So our answer is 3n squared. And there we go. I think we may have, how many more? Okay, that one's writing an irrational, evaluate. Maybe we'll do, I think we'll do these 2 and then we'll be done with this one. Then we're going to move on to today's slide and we're going to do a little bit of that and we'll probably be done in probably not that long. I'm trying to keep most of these under an hour. I think an hour is a good time because since I'm making a video of these as well, I don't want people, you know, watching hour-and-a-half long videos. And again, we don't need every single example. I'm just trying to give you enough to do your work so that people don't get frustrated or overloaded on things. So here I have 2 more examples of evaluating. And again, evaluate means everything. And I don't have any other things going on, so I don't need to multiply or add any exponents. So I'm going to go ahead and turn it into a radical expression. There we go. Bottom number here becomes the index, and 2. And then we have a couple of different ways we could do this. We could take 27 and square it, and we'd get something like, I don't know, we'd get a pretty big number, but we'd have to find the root of that. But one other thing you can do, and I did say that I was going to show you some other ways in case you don't have a calculator, or, you know, because you never know. Some people may not have calculators, or maybe you have a calculator, but you don't have a cube root function. But since you are here, I'm also going to assume that you have internet. So one thing you can do to go on internet is to, oopsie, go to Desmos. So let me show you how to get there. I think most of you guys already know if you were in my Algebra 1 or any of my previous courses, like Desmos is like the thing that we always use. So DESMOS, and you should immediately get the first thing that says graphing calculator. And there you go. So this calculator I know has cube root function. My calculator here, the calculator on my computer desktop does not have cube root. So to get the cube root, go to the keyboard down here, open that up. We have a root here, but remember this one has no index. So if there's no index, that means we are looking for the square root. We don't need the square root, we need the cube root. So I'm going to go ahead, go to functions, slip all the way to the miscellaneous tab. And we have nroot. So click on the nroot button, and it allows us to put our own index in there. So I'm going to go ahead and put 3 as my index. And I think I could even put in the whole expression, 27 squared. So I'm going to push the square button. So this is the any number square button. And we get 9. So that's an easy way to take care of all these things, you know, before they become really big numbers, or if you have a calculator. But again, I'll show you some other ways that we can do this without a calculator. Okay. Okay, I think I see I think I know what the problem is and why the, okay, I think I figured it out. I think I know why the screen leaves you where you were. Okay, so I think I fixed it. I think you can probably see my calculator screen now. But again, you just go to Desmos, DESMOS online. Let me just show you how to do this again really quick. So you go to functions, in root, and in root allows you to fill in the root. So I'm just going to type in 27 squared and we get 9. And that's pretty much it. So hopefully you guys can see that now. I think I figured out why the screen share does that. I think I have to switch over to the screen share every single time I move to something else. So anyway, here we go. Yeah, and if something comes up like that, just let me know. All right, just let me know if there's an issue, because the sooner I know something's going on. Just like yesterday, I think I was talking and the mic was muted. That way it saves everybody a little bit of time. So I'm gonna put 9 here and we're done. All right, now with this next one, I'm gonna kind of show you again another way that you can do this without using the calculator. And that is to take care of your problems before they become big problems. Okay, so let's go ahead and move this into a radical expression. Let me make sure I'm sharing. Okay, I got the right screen going. I think I have to push the button every time I'm switching screens. All right, so root. In this case, I need square root and 5. Make that 5 a little bit better. Now I'm going to expand it out, which, yeah, you will have to do a lot more writing. But again, if you don't have a calculator or something, then this way might be the best way. So 36, and remember what this power means. The power means you are multiplying that number times itself that many times. Now again, even if you have a calculator and it's not a very good one, you might have a lot of numbers, because most calculators only allow a certain number of digits on the screen. So even if you had a calculator, it might not be able to do this problem, because 36 times 36 times 36 times 36 times 36 would get to be a really big number really, really quickly. But luckily we won't need that, because we're going to take the square root of all of these 36s. So square root of this 36, that's 6. Square root of this 36, also 6. And each one of these is going to be a 6. All right, make sure they're all there. I'm going to bring up my calculator. I'm not sure if you can see the calculator on my screen, but it's just the one from the computer, the desktop one. So I'm going to punch in 6 times 6 times 6, 5 times. And I get 7,776. There you go. We evaluated it. We have no more operations to take care of. So that term is, that expression is fully evaluated. Now, one thing that I also noticed that people do is they call everything an equation. But that's also kind of a myth, or what do they call it? A misconception. Because in math, not everything is an equation. If you don't have an equal sign, then it's called an expression. I think I've even heard other teachers make that mistake as well. So it's a big thing. Okay, so there we go. We're done with that. I'm gonna go ahead and move on to this next one. It's gonna be a little bit of the same thing. So this is the same slide you saw yesterday with a to the fraction exponent power. But again, I'm going to kind of skip to the main ones that we need to work on in order to do our homework assignment, and that is going to be these ones. And I think we're going to do this one, 2, 3, 4, and I think we just went to 6. With all my other classes, I only went to 6, and that was pretty much it. And you should be able to do both of the assignments like this. So if you need a minute or two to copy this, I'm going to go ahead and, you only need to copy these definition parts up here, because you're going to be needing those same things for the work, which I don't remember if it was on there, but I don't think it is. So just these 3 things up here. So I did say I was going to talk a little bit more about what math was and how things work. So this is something I usually give a bit of a talk about each time, and why we do math, because I always get that question from maybe 1 or 2 students every single year, is why do we have to learn math? You know, when am I ever going to use this? So if you're going to go out into the world and look for exact opportunities, you're going to be using these exact principles, you're probably not really going to find that many of them, unless you work at a job where you do a lot of this sort of stuff. But I'm guessing that's probably not most people. But really what math is supposed to teach you is how to use rules and how to work things and how to solve problems, not math problems, but solve any kind of problems, right? So when I was talking about how things work, even though you can use a calculator, sometimes it's a good idea to train your brain, you know, train your brain to do things. And no, video games is not training your brain. So anyway, that's all I wanted to say about that. And there's a lot more other things of stuff going on. But I'll probably save that for another day. Anyway, so let's go ahead and get right into what we're supposed to be doing here. And that is using this property here. So I have the same base, right? 5, 5, it's the same number. If you're multiplying 2 numbers that have the same base, but different exponents, well, actually, even if they are the same exponent, but they both have exponents, then you add those exponents together. Now here's where things are a little bit different, because when you are adding fractions, you follow a different set of rules. So I'm going to go ahead and set it up. I'm going to put these 2 bases together, kind of like here where we have A, and I'm going to add them together, kind of similar to what I did with the multiplication ones too. To multiply them, I just sort of put them together. Like that. So now we're adding those exponents together. Now with fractions, there's a different set of rules that you must use if you are going to add them. All right, so if you're going to add them, just a quick recap on how to add fractions. You got to make sure the bottom number is the same. Okay, you got to make sure that bottom number is the same, because if they're not the same, then you need to change it. But I checked the homework. Nearly all of them are already the same, so you don't have to worry about anything else. So in order to add the fractions, top number plus top number, so 1 plus 3. Okay, don't make that mistake of thinking it's like times. All right, so 1 plus 2 is 3, not 2. And the bottom number, so the bottom number kind of does a strange thing, and this is only when you add or subtract fractions. The bottom number stays the same. All right, so it stays the same, and again, I could probably explain why it does that, but that would take a whole other lesson pretty much. But again, check your exponent, make sure that you can, in this case, I can divide it. I can divide it because 3 times 3, I'm sorry, not times, 3 divided by 3 is 1. And remember, anything to the 1 power is just a regular number. Right? So if you times anything by 1, you're going to end up with the same thing. Right? So if you walk at 1 speed, then that's how fast you normally walk. Okay. Now let's go ahead and do the next one. So this one here is the same one that we did in the previous one where you are raising a power to a power. So with this one, I'm probably going to go through it a little bit quickly, because again, we covered this one in the last lesson. So 7 to the 1/3, and I don't really need these parentheses because I am going to be multiplying them together. That's what this means. So power to a power means you multiply those powers together. Now for this next number, I have a whole number, which the homework does have these as whole numbers. So if it helps, and this is probably a good rule to use whenever you're working with fractions, is if you have a whole number, always put a 1 on the bottom, so that way it makes it a little bit easier to work with. I guess you don't always have to do it, but it makes it easier to kind of see where the numbers are going. Now, from here, I follow the same rules. Top number times top number. So 6 times 1 and 3 times 1. Now again, be careful because they will handle differently depending on whether you're multiplying them or adding them. Remember, adding them is different and the bottom number does not change when you're adding them. But if you're multiplying them, well, if this was any other number, then I'd have to change it. So again, they're a little bit different. Be careful with that. Check your power. Make sure you can divide or reduce it, which in this case, it looks like we can reduce 6 over 3. 6 divided by 3 is 2. And we could probably evaluate this even further and go to 49 because 7 squared is 49. Okay. Last property. Now for this one here, I don't think there's any of them in the homework for this one, but I think it's going to come up later. So it's probably worth going over, but that's okay. It's not really a tough property to go into. It's basically like distributive property. So if I have A times B raised to the m power, I can distribute that power to both A and B if it helps. Okay, sometimes you will have expressions with numbers and variables, because one of the other questions I usually get is, why do we have to know this property? So if we look at this example, one of the first things someone might say is, well, can't we just multiply 4 times 25? I mean, they're in parentheses anyway, so why won't we just multiply that? 4 times 25 is 100, and square root of 100 is 10. Okay, can't argue with that. But again, sometimes you will have things come up differently. Sometimes you will have, like, what if instead of 4 times 25, you have, say, 4 times x? And again, I know we're going to be working on some of these later, so better that I introduce it today and see how, work on it, and that way we get familiar with it, we have more practice with it. So I'm going to go ahead and distribute this half power. So that means 4 to the 1/2 power times 25 to the 1/2 power. And just like when you change it over to a radical expression, so remember you have your number, and this number becomes, the bottom number here becomes the outside number. So in this case it's 2, so my index is 2, so we're taking the square root of this number. Right, but we don't really need that, but one other kind of mental shortcut is anything to the half power is just divided. I'm sorry, not divided. What am I talking about? The square root. It's just the square root of that number. So we can take the square root of 4 and the square root of 25. So square root of 4 is 2, square root of 25 is 5. Multiply those together and there we go. That's it. And there we go. That's an example of how all of those properties work out. And like I said, let's do 6 more and then that'll be it for today. We did get started a little bit late, but again, hopefully once people start showing up on time and everyone kind of knows where to go, I had a lot of emails to get to before the class started. And lunch is a weird thing too. All right, so these three things up here are the same thing. So if you already wrote them down, don't worry about it. It's still the same thing. And again, I plan on posting this video later. So if you need more time on something, or if you missed something and you didn't want me to stop or go back, then I'll post it and you can just replay the video. And again, it's also helpful for the people who aren't here or can't make it to classes like this. Who knows? We might even someday have less of a need for Zoom. But anyway, let's just get through this for today. So take care of this here. Do the same thing, set it up to multiply. So 8 to the 1/3, right? And it's usually easier to work with fractions when you have them directly on top of each other instead of using the slash. 2/1 is 2, right? So it just makes it easier to work with fractions if you turn it into a fraction. Now be careful because it's not the same thing. Like if I have 2 and I put a 1 on top of it, that's not at all the same thing. Okay, this is like $2 and this is half of a dollar. So no, they're not exactly the same thing. Multiply them together, 1 times 2, 2 times 3. Now, if it said turn it into a radical expression, we would be, or sorry, a rational expression, we would be done with this by now. But again, the directions say evaluate. And evaluate means do everything. So if I still have an exponent, then I should fix it. So let's put it into a radical expression. Hopefully you're getting the hang of this now. Okay, that's a really weird looking 3. It's almost scary looking. Like if you were watching a horror movie and they put a 3 like that, that would be the scary 3. Anyway, so we can also take care of this exponent here with the 8. So 8 squared, that's an easy thing to do. We get 64. And remember what this means. It means we need 3 numbers to multiply to get 64. So what 3 numbers can we multiply? And I know usually the first things I'm going to get are 8 times 8. But that's 2 numbers, not 3. We need 3 of them. And then I usually get something like 2 times 32. Well, that's good. We could break down 32 some more. But let's try something a little bit different. Let's try 3 numbers. So let's try 4 and 16. I can still break 16 into 2 more numbers. And I end up with a set of 3. And remember, that's what this index means. It means I need 3 of those same numbers to get 1 of that number. Because this radical is like saying 1/3. Right? So an example of that would be this coffee can. So if I wanted to split this coffee can 3 ways, I would probably, like let's say one of the other teachers or 2 of the other teachers want some of this, then I'd probably have to split it right here and maybe right here. So that's 1/3, 2/3, 3/3. So now if I put them all together, I have 1 coffee can. And that's kind of what this means. 1/3 power means if I put all of them together, then I'm going to have 1 of these numbers. And since I have 4 number 3s, when it comes out of the radical, there's only 1 of them. So the answer is 4. And there we go. That's it for that one. Let's move on to the next one. So in this next one here, I have 4 times 16 to the 1/2 power. Now, if I were to multiply 4 times 16, that would be, well, 64, and then I'd half power that. And again, that's probably the easier way to do this, but let's practice using this because we're going to need this later for other lessons. So I'm going to distribute this power. So again, it behaves just like distributive property, something you might have learned in like 7th grade or something like that. And now they're both to the 1/2 power. And remember from earlier, 1/2 power just means square root. So I took the square root of both of these numbers. Square root of 4 is 2, and square root of 16 is 4. Two times 4 is 8. And that takes care of that. Okay. I'm not sure if you can hear that, but it sounds like somebody's walking on the ceiling again. But then I don't know if there's a place on the building where people can walk outside on the roof. Probably just demons trying to force their way into our world again. Why can't they just leave me alone? Okay. And like I said, we got these two, maybe one more, and we'll call it a day from there. Okay. So we need this first power. So I got, this first property, because I have two numbers that are the same and they both have exponents. So remember, if I have two exponents, that means I just add those exponents together. I said add, I almost put a multiply there. See, you gotta watch yourself sometimes. Everybody makes mistakes every now and then. All right, so there you go. I set it up so we could add the exponents, add the powers. So again, top number plus top number, so that's 4. And remember, when you're adding or subtracting fractions, you leave the bottom number the same. Leave that bottom number the same. So now we check it to see if we can either divide it or reduce it. Which in this case, I can divide it because 4 is a bigger number than 2, and 4 can divide by 2. So 4, and our new power is 2. And now we just square 4, and we're done. That's it. Evaluated. We took care of everything. There's no more pluses, minuses, divisions, or multiplications, powers, roots. We took care of everything. All right, so for this one here, it looks like we're going to need this middle power here. So set that up. 3 1/2 times 2/1, and I know where this is going. And remember, 1 goes on the bottom if you're going to make it into a fraction. So 3, 2/2. So 2/2. We can divide that. It's going to be 1. 3 to the 1 power. And again, 1 power just means regular. So that just means regular 3. There we go, not too shabby. Okay. 2 more, and I think we'll go ahead and call it a day from here. It's not, well, what does the schedule say? What time does third hour end? 1:07. Ooh, so it ends in like 2 minutes, which is fine. That's probably exactly where I was aiming for. All right, so let's do this last one and we'll call it a day. Now here's another example of taking care of your problems before they get big. So 27 times 64, that's a big number, right? And you're still gonna have to take the third power of that. So let's go ahead, and what I'm gonna do is I'm gonna take the cube root of 27 times the cube root of 64. And again, you can break it down like we did yesterday, or in my case, I'm going to go ahead and use Desmos again. So move back over here, and I'm going to even save the little number. So I have, I think it was root 27 times cube root. So I'm gonna go ahead and put the cube root button back on. What was the other one? 64? I think it was 64. Let me just take a peek. Yeah, 27 and 64. Oopsie, it's not letting me because, let me just put a 1 right there. And there we go, we got our answer. Now I just put the 1 there. I don't think I had to put, if I had to delete it entirely, it confuses the computer when you put extra numbers in there. So that's why I was telling you to leave certain numbers off if you don't really need them. So there we go, we got our answer for that one. Actually, switch back to the other screen. And we get 12. There we go. Last one. Again, looks like we have 2 bases of 2, 5/2 plus 1/2. 5 plus 1 is 6. And again, when you add or subtract fractions, you don't change the bottom number, so it stays 2. Now, divide it, which we can, because 6 is a bigger number, and 6 can easily divide by 2. 2 to the 3rd power. 2 to the 3rd power is 8. And we are done. That will be it for today. So thanks for joining me again, all you wonderful people. I'm going to leave it here for just a bit, and I'm going to go back to the other screen while we wrap things up. So again, computers are coming probably on the 31st. Packets also count as attendance as well, so I don't know. We're still sorting things out. I think one of the other things I said was Schoology will be open soon. And I think someone brought up yesterday putting notes in the work. So I'll try to do that for next week. But it all depends on how the paper situation is going. Until we see next time, then we'll go ahead and well, I'll let you guys go. See you later. Bye now.